Hello and welcome back. We are covering more on identities, so 1.5. Take notes. So in the last section, we learned about identities, but we didn't really use them a whole lot. But in this section, you will. Okay, so in this section, we're going to be looking at how to rewrite certain trig expressions, or we might take a trig expression and we might simplify it, or we might have an identity and we need to verify it. Okay? All right, so here in this section, we're going to take a look at reciprocal identities. Actually, those are the ones we looked at before. We looked at reciprocal identities. We looked at ratio identities. And we also looked at the Pythagorean identities. And I will write the Pythagorean identities here. We have the one cosine squared plus sine squared equals 1, and that came from Pythagorean theorem. And then we took this one and we derived the other two by dividing both sides by cosine squared and then dividing both sides by sine squared. When we divide both sides by cosine squared, we end up with 1 plus tangent squared theta equals secant squared theta. If we divide both sides by sine squared, then we end up with cotangent squared plus 1 equals cosecant squared. Okay, so these are the three Pythagorean identities that we looked at in the last section. So now we're going to go ahead and take a look at using these three types of identities: reciprocal, ratio, and Pythagorean identities. Okay, if you remember reciprocal identities, that's like sine theta is equivalent to 1 over cosecant. Okay, so those the ratio identities are the ones with tangent and cotangent. Tangent is sine over cosine. Cotangent is cosine over sine. Okay. All right, so let's take a look at this first example. Write tangent theta in terms of sine theta. So again, all of this comes in handy later on in calculus, because sometimes you want to do something like integration, and you need to integrate an expression, and there are certain rules, and you're like, oh, I don't know what the rule is for this one. There isn't anything. I've looked, and but then it turns out if you can rewrite that expression, then you can do that thing called integration. Okay. Anyway, so tangent theta, we want to take this and rewrite it in terms of sine theta. Okay, so we know from the ratio identities, we know that tangent is sine over cosine. Okay, so we're getting a little closer. We at least have sine here, right? But it says to write tangent in terms of only sine theta. So that means we have to somehow get rid of cosine theta by rewriting it in terms of sine theta. Okay, so right here, we do know that first Pythagorean identity. We do know that cosine squared plus sine squared equals 1. So if I solve for cosine squared, I would have to subtract sine squared from both sides, right? And then I get cosine squared theta equals 1 minus sine squared. Okay, but I need to solve for cosine, not cosine squared, so I'm going to go ahead and take the square root of both sides. Okay, so when I take the square root here, it will cancel out the square. But when I take the square root there, I have to do plus minus. So it turns out cosine theta is equal to positive or negative 1 minus sine squared theta. Okay? All right, so we do have this. So now I can go ahead and replace the cosine theta with what we just found. So now I have sine theta in the numerator, and then down below, I'm going to go ahead and replace cosine theta with what we got over here, which is plus minus, and it does matter, you can put the plus minus out there, 1 minus sine squared theta. Okay, and now I have tangent rewritten in terms of only sine. Okay? Okay, let's try another one. If you think you want to give this next one a try without seeing how I do it, you can always pause the video. So let's write secant theta in terms of sine theta. Okay? All right, so hit the pause button if you want to try it without me, or continue watching. Okay, so secant theta, so we want to write it in terms of sine. Okay, well, we know secant is the reciprocal of cosine, so let's start there. And in the previous problem, we found out that cosine is actually plus or minus square root of 1 minus sine squared. So I can replace the cosine theta over here with this. So I get 1 over, and I could put the plus minus there, 1 minus sine squared theta. Okay, and now I have secant theta rewritten in terms of sine theta. Okay, so that is all there is to that one. Okay, they do get a little more complex, so let's take a look at this next one. Write secant theta, tangent theta in terms of sine theta and cosine theta. Then simplify. All right, so we have secant theta, tangent theta. We want them in terms of sine and cosine, so I'm going to use the reciprocal identities and the ratio identities. So secant theta is 1 over cosine. Tangent theta is sine over cos. Okay. So we have this here, and it turns out 1 times sine is sine theta, and then cosine times cosine is cosine squared. Okay, and it says to write it in terms of sine theta and cosine theta, so I'm going to go ahead and stop right there. If it had said, like the previous examples, write it in terms of sine theta, then I could easily rewrite this using this up here. The fact that cosine squared is equal to 1 minus sine squared. Okay? But it doesn't, so I can stop right here. Okay? All right. And let's take a look at adding and multiplying. So suppose that I have this here, 1 over sine theta plus 1 over cosine theta. Okay? So just like any other kind of fraction, if you're going to add or subtract fractions, the denominators have to be the same. Here they are not the same. One of them is sine theta, the other one is cosine theta. So I need to get the LCD, the least common denominator. In this case, it would be sine theta cosine theta. So this is what I want the denominators to look like. in order for me to add them. Okay, so if I take a look at this first denominator, we only have sine theta, but we want it to say sine theta cosine theta. Okay, so then that means I need to multiply by 1 written in the form of cosine theta over itself. Okay? And when I do that, I get 1 times cosine theta on top, which is cosine theta. And then I get sine theta cosine theta for the denominator. Okay? And that's what I want. I want the denominator to be this common denominator here. Okay? All right, the next fraction, I have cosine theta, but I want it to say sine theta cosine theta. So I need to multiply by 1 written in the form of sine theta over sine theta. Okay? And when I do that, for the numerator, 1 times sine theta is just sine theta. And down below I get cosine theta sine theta, which I can rewrite as sine theta cosine theta. Alright, so now with these two fractions having the same denominator, I can go ahead and add these. And when I do that, I get cosine theta plus sine theta over sine theta cosine theta. Okay? And that would be it. Okay? And let's take a look at multiplying. Suppose you have to multiply this binomial, 2 cosine theta plus 1 times 3 cosine theta minus 2. Okay, so just like any binomial, you want to do the distributive property. Okay, so just like if you had this, when you had to multiply these two binomials, you would do x times this, x times that. Then you would do the distributive property with the 3, and you would distribute the 3 there and there. Okay, same idea here, same process. You're going to use the distributive property with 2 cosine theta. And then once you're done distributing the 2 cosine theta, then you'll do the 1, and you will multiply everything in here by the 1. Okay? Alright, I'm going to go ahead and rewrite it down here so we can show some work. Okay, so starting with the 2 cosine theta, I'm going to multiply 2 cosine theta with 3 cosine theta. And that gives me 6 cosine squared theta. Okay? 6 cosine squared theta, because 2 times 3 is 6. Cosine times cosine is cosine squared. And then I'm going to distribute it over here. 2 cosine theta times negative 2 is negative 4 cosine theta. Okay, I'm done distributing the 2 cosine theta, so now I'm going to go ahead and distribute this 1. 1 times anything is itself. So I get 3 cosine theta. And then 1 times negative 2 is negative 2. And now I'm going to go ahead and combine like terms. I see that over here in the middle, we have like terms. Okay, so I'm going to bring this down, 6 cosine squared theta. And now combining these two like terms, negative 4 plus 3. Negative 4 plus 3 is negative 1. So I get negative 1 cosine theta. I don't need to write a 1 there. It's understood. And then I'm going to go ahead and bring down this negative 2. Okay? And that would be my final answer. Okay? Okay, and let's take a look at simplifying. Suppose that you have to simplify square root of 16 minus x squared as much as possible. As much as possible. After substituting 4 cosine theta for x. Okay? All right, so we have the 16 minus x squared. So the first thing I need to do is substitute 4 cosine theta for x. So let's go ahead and do that. Let's go ahead and replace the x with 4 cosine theta. Okay, and I need to square the 4 cosine theta. So everything in there is going to get squared. So 4 squared is 16. Cosine squared is cosine squared. Okay, so this is what I have now. Okay, I notice that they both have 16 in common, so I'm going to factor out the 16, and I get 1 here minus 1 cosine squared. Okay, and 1 minus cosine squared, we've seen that before. Let me scroll all the way to the top here, to the beginning. 1 minus cosine squared. We can obtain that from this first Pythagorean identity. If I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared. Okay? For those of you guys who need to see it. So if I have cosine squared theta plus sine squared theta equals 1. If I subtract cosine squared, I get that sine squared theta is 1 minus cosine squared. And that's what we have on the last problem. We have 1 minus cosine squared. 1 minus cosine squared is the same as sine squared. So over here, going back to this problem. Okay, so right over here, so let me write that down over here. So we know that sine squared equals 1 minus cosine squared. Okay, from the Pythagorean identity. Okay, so then I'm going to go ahead and replace that. So the 16 will stay, but instead of writing 1 minus cosine squared, I'm going to go ahead and write sine squared. Okay? Okay, and then here, square root of 16 is 4, and square root of sine squared is sine theta, but we want to make sure that we take the positive result, okay? Because sine theta, like let's say the answer to sine theta is -1, and we square it, right? Then that kind of changes things here, but when we take the square root, we want to make sure that we take the square root of the positive sine theta. Take the positive result, okay? So we put the absolute value there to make sure that we have the positive result, not the negative, okay? All right, let's see. Okay, so that's the end of this first part. In the next, in part 2, I will cover verifying identities, which is a lot of what we're doing here. So here we're doing a lot of simplifying, and verifying identities is basically the way you do it. It's the same process because you have to verify. So in order for you to verify that the two expressions are equivalent, what you have to do is essentially simplify. And when you have an identity, it's like you have to choose one of the sides and simplify it. It's basically giving you the answer on the other side. They're saying, okay, simplify it, and your answer should look like this. See if you can do that. Okay? All right, so that ends this part. You should be able to get started on your homework if you are ready. If you have more time to watch the second part, I will see you there.